Hi, everyone. I'm Andy Gutmans. I'm the general manager for Amazon Elasticache. I also manage Amazon Elasticsearch Service and Amazon Neptune, our new graph database. I know it's right after lunch right now. This music was super relaxing. If you don't fall asleep, I promise I will try not to fall asleep myself. So stay alert. Redis is all about speed and high performance and just-in-time rapid application development. So you definitely have to stay awake. How many of you are not using Redis today? Okay, that's quite a few. I really hope that by the end of this session, I whet your appetite for Redis, and you'll see why I think it's such an awesome technology. Out of those who are using Redis, who's not using Elasticache? Okay, quite a few. So I guess I have two goals today. For those who don't know Redis, I'll try and whet your appetite, and for those who are not using Elasticache, maybe give you some reasons why you should give this service a try. What I'll do today is talk about Redis, why I think Redis is awesome, and some of the new things that have come along in Redis. I'll talk about Amazon Elasticache service, and specifically Amazon Elasticache for Redis. Talk about how customers are using it, talk about some of the use cases, and then I'll also give you a bit of a glimpse of what's new in Elasticache if you haven't looked for a while, and what some of our kind of short-term plans are around Elasticache. And we do have a full 60 minutes, so if we have some time left over, I'm more than happy to answer any questions that you have. If we run out of time, we can gather on the side, and I'm happy to answer any more questions you have. So to get started, I wanted to give you a bit of a context on how we think about Redis at AWS and how it fits into our database portfolio. Our focus is really on delivering the best purpose-built databases. And there are a number of purpose-built databases we deliver. And the reason why we have multiple databases and not just one is because application development requirements are really changing rapidly. And it is really hard to find one database that's going to rule them all and solve all the problems. So data volumes are exploding. You know, we're not in the gigabytes anymore. We're in the terabytes. And if you look at the analytics side, petabytes and even exabytes of data. Applications are not simple request-response monolithic applications where 250 millisecond database query is good enough to meet your end user requirements. We're seeing microservice-based architectures, lots of API calls, lots of database calls in the back end. To the point for many of our customers, if we can deliver single-digit millisecond latencies on database calls, some of those applications aren't going to perform well. And we also get requirements for sub-millisecond response times in the microseconds. We're not dealing with tens of thousands of requests per second anymore at the database tier or hundreds of thousands. We see customers who actually need to do millions of requests per second. And that's not even concurrent users, right? That would be like 100 million concurrent users, but that could be millions of requests per second. That's really, really hard to do. And then in addition to that, we've got to build these applications really, really fast and more feature-rich than any time before. So there really isn't going to just be one way or one database that's going to solve that. There have been attempts at that, like the relational database vendors started to add key value capabilities, document capabilities, even graph capabilities. But I think what we've learned is every database has a purpose, and if we focus on delivering the best tool for the job, you guys are going to know how to take advantage of that and really deliver awesome applications. And probably the person that says it best is Werner, our CTO. He wrote a really good blog. If you haven't read it, I suggest you read it. Basically what he says is one size fits all databases doesn't fit anyone. That's pretty much what I'm saying. You're not going to find a single database that is going to fit everything that you need to get done. And the reason is we just have a lot of different models that we're trying to represent within our applications, right? We have the traditional relational model, which is super valuable, right? It's ACID, it's strong schema. Those databases aren't going to go away. We have Aurora, which is a very, very awesome database, and is growing very, very fast. But then we also have databases like Dynamo, a key value database that gives you a single-digit millisecond response with DEX, even microsecond response, but really gives you pretty much infinite scale. And so for certain use cases where you need the highest availability you can get and super low latencies, that's the kind of database you'd want to use for specific capability. Then, of course, there's document, there's graph. Graph is really focused at extracting the maximum value out of the connections between data points. And that's why we launched Amazon Neptune in May. And then last but not least, what I'm going to be talking to about is in-memory and in-memory databases, and Redis really being the leader in the in-memory database space. What's really special about the in-memory databases is they don't have to worry about how data gets persisted on disk and what the right data structure is, so you could actually also write this thing to disk in an effective way. The focus for in-memory databases is exposing really useful and viable data structures to developers that can both deliver a lot of functionality, but can also deliver super high performance. And so I don't need to go away just thinking it's just about performance. It's also about the convenience and the convenience of the data structures that we can much more easily represent in memory than we can represent elsewhere. So how does Redis fit in? Redis is really awesome at low latency. Most of the requests will basically return in under a millisecond. It's not atypical to see about 350 microsecond response times. Redis is also very good at high throughput, especially if you look at things like caching use cases. Being able to use a single instance and do about 200,000 requests per second can not only help you deliver awesome apps and awesome end user experiences, but it can also dramatically take down the cost of your overall application. And I'll show you an example of a customer who actually was able to deliver that. Some really interesting use cases, I'll talk more later on about them, like ride hailing, social media, gaming, media streaming. A lot of these born for the web applications, they need to reach hundreds of millions of users and need super low latency. And while it's in memory, we don't just measure Redis's capabilities in gigabytes. We can actually deliver terabytes of data in memory through our bigger instances and sharding. And actually on Elasticache for Redis service, we can do up to 170 terabytes of data in a single cluster. So don't only think small. And later on, I'm going to talk about a new feature in Redis, which I think is going to become super appealing. And in that use case, I definitely think terabytes of data may definitely become the norm. We talked about microsecond latencies with about at least 200,000 requests per second per machine. It doesn't take a lot to actually get to millions of requests per second on Redis. And last but not least, it's an open API, it's open source, there's lots of client libraries out there. The actual interface is very, very convenient to use, and I'll talk about that a bit more later. And so from the AWS perspective, as we look at our purpose-built portfolio, Redis is really kind of our primary database for the in-memory use case. So a bit more about Redis. For those who are new to Redis, it is the most popular in-memory database, according to dbengines.com. Also, if you just look at all general databases, whether that's relational or search or document, key value, Redis is consistently in the top 8 databases in the market. So super, super popular, being used across the globe by many applications. And like many of its open source peers here, has just gotten huge distribution through the open source model and through Linux distribution and other vehicles. So what makes Redis so awesome? So we talked about the speed. I talked a bit about the simplicity and the easy-to-use API. Another really awesome thing about Redis is it actually supports replication. That's not that typical. Like if you remember Memcache is super fast. It's a key value store, but it doesn't really give you that kind of replication and that kind of availability. Redis does. So you can actually build a cluster of Redis with read replicas. Talk a bit later on how we leverage that to deliver more scalable and available systems. But that's really at the core of one of the things that makes Redis really special. There are over 200 commands, and those commands, a lot of them are geared towards manipulating really interesting, sophisticated data structures. So probably the easiest way to think about Redis, it's a data structure server. It's got lots of data structures like lists, like hashes, like sorted sets, streams, and you can use those data structures really to best optimize for the use cases. And I'll talk about some of the use cases and what data structures you would want to think about as you're building applications with that use case. And last but not least, even though it's in memory, and in memory, of course, isn't persistent, Redis does have a nice snapshotting capability, so you can actually take periodic snapshots and back up your data and then rehydrate clusters with those backups through a restore mechanism. So it's a pretty awesome in-memory technology, lots of options around data structures, and lots of enterprise-ish capabilities like replication and backup and restore. So what are some of the use cases? The first most popular use case has been caching. And there are lots of variants on how you apply caching. And caching is usually a very simple key-value kind of relationship. So there's a key, the value is a string, so it's not really a sophisticated data structure. And that's what I will call kind of the simple caching use case. But the nice thing is that Redis also supports maps. It supports lots of other data structures. So for example, session stores, session management is probably another primary use case for Redis. You'd often use a hash map for that, because in a user session, you actually want to store multiple attributes. If you build a chat application, Redis has a pub/sub mechanism where you can actually do a publish and subscribe. I'll talk a bit later about a new data structure that's come along and how that potentially could eclipse the pub/sub capability in Redis that existed until today. But so far, there's just a lot of choice, and those choices often match up with specific use cases. Redis is pretty much a de facto standard for gaming leaderboards. So if you're playing games or kids are playing games and you see the leaderboards, I would say it's probably 80% chance, and that's a guesstimate, not a specific number, that behind the scenes, it's actually a Redis sorted set, keeping the leaderboard for the real-time gaming application. And what's of course very typical in gaming is you have super high volume, super high requests per second. And so being able to do a leaderboard at scale at a relatively low cost is really one of Redis's sweet spots. Redis is getting a lot better. So October 17th, new version came out, Redis 5. I'm super excited about Redis 5. Redis 5, I think, is really a major version, unlike the major versions we had before. It adds a new data structure called Redis streams, which initially was actually slated for Redis 4, but it took longer to develop, and it actually ended up being released under Redis 5. And that's a new data structure, which is a log-based data structure, which is optimized for streaming use cases. And there are a lot of possibilities around Redis streams. Some I'm going to talk about today, some I think that you're going to discover as you play around with Redis. But that specific feature, in my opinion, is going to give Redis additional tailwind in the market and is going to continue to accelerate adoption. And I'm going to dive a lot deeper into what Redis streams is, how you should think about using it, and what kind of use cases it could potentially address. There are lots of other additions in Redis 5, so an optimized hyperlog-log algorithm. But for those who don't know what hyperlog-log is, it's a way to basically estimate how many distinct values you have in a set. Super useful for a number of applications. And that contribution was actually made by the person who wrote the paper that described a new, better, faster, more optimized hyperlog-log algorithm. So a really nice community contribution from the person who actually did the research all the way to implementation in Redis. Redis 5 also upgraded the JMalloc memory manager. And so it is higher performance, has less fragmentation, and in general is another step up for memory management. Obviously, as an in-memory database, memory management is super critical, especially as Redis will run for a very, very long time, and we need to make sure that fragmentation stays down. And then just lots of other enhancements. Sorted sets have gotten, pop and block operation support, lots of bug fixes, lots of performance enhancements, and fresh off the press. We already support Redis 5 and Elasticache for Redis. It took us less than 4 weeks. Part of that the release date for Redis was known up front, so that really helped us and I'd say the rest of the community to prepare and make sure that we could test it, secure it, and offer it on the service. Now, we published a blog post that actually goes through in a lot more detail on what's new in Redis 5. So if you go to the following URL, aws.amazon.com/redis/what's new Redis 5, you can read a lot more about Redis 5, the new features, and how you can take advantage of them. But for now, what I would like to talk about is Redis Streams, because that is by far, I think, the most impactful feature and the most interesting feature in Redis 5. It actually made me spend hours and hours of playing around with it and reading about it, and I'm personally super excited. I don't get a lot of time anymore to geek out with the tech, but this definitely caught enough of my attention that I spent a considerable amount of time on it. So the way to think about Redis Streams, it's a kind of timestamp indexed append-only log. So basically, these records come in, they get timestamped by Redis, typically, and they're basically stored as a log. It leverages the fact that Redis is high performance, so it can really deal with log flow that's coming in very, very fast. And some of the things you may want to put in there are, clickstream analytics from your web application or chat application. You could use it for message queuing. There are lots of ways to use streams as an underlying primitive to build applications on top of it. I'm going to touch on a few of those. Going into a bit more detail, Redis Streams was basically implemented as a radix tree. It was implemented by Salvatore Sanfilippo, who is the creator of Redis. And he built a really nice radix library called Rex. That is open source on GitHub outside of Redis, because he felt like this was an awesome implementation that people could actually use for other use cases. So if you're a C developer, you like playing around with these things, you could also get this implementation outside of Redis and use it in some of your applications. What's really special about radix trees and how we implemented it is that it provides super fast lookups. It gives you sorted range queries, which are used here for the timestamp queries, and it really reduces memory usage. So it's very, very frugal on memory usage, super fast, and gives you really nice capabilities, especially the time ordering. If you look at the little sample message I put up there, and I'm going to go into a bit more detail, I'm kind of going to show you a small example of how you could think about a chat application within the Redis Streams context. But just to give you an idea of what like a single log entry could look like, it would have an entry ID. That entry ID is timestamped. It also has a sequence number, just in case 2 messages come in at the same time. We still want to be able to distinguish between them. So Redis actually takes care of that for you. And then within a message, I can put as many kind of key value pairs as I want. So in my little chat application, I put the message, which in this case is hi, and I put the user ID who actually wrote the message. And then you have consumers who basically make Redis connections and make TCP connections to the Redis server, and they can start reading from this log. And as long as that log hasn't been trimmed, anyone who has permission can actually come in and read the log and do what they want. What makes it really powerful is I mentioned earlier that Redis used to support pub/sub. The problem in the Redis implementation of pub/sub, if something goes wrong, like the client by mistake disconnects and then wants to reconnect, that message may be gone. In this kind of streaming capability, that message sticks around for quite some time until we decide that we have too much in memory and we want to trim the log. And so if you have a disconnection, the client can just come back, reconnect, kind of remembers what it read last, and then use a range query to basically read from that point onwards. And so that model really delivers a lot of opportunity to build really sophisticated log-based applications. Redis streams also copied an idea from Kafka. And I don't know if Kafka invented it or copied it from somewhere else. But that idea is called consumer groups. Consumer groups is a special feature on top of this, which basically guarantee if clients are using consumer groups, it means two things. One, the Redis server actually knows who the clients are. And the second thing is consumer groups will make sure that every piece of data is only read by one client. And so it basically guarantees that a record is only processed by one client. And that is also a really cool feature, because if you think about something like implementing a job queue, you could, through the system, have multiple worker processes, right, or worker servers, but make sure that every job is only executed once by a specific worker. So that probably gives you a bit of a taste of the kind of flexibility you get here. You both have kind of the general log, where anyone can come in and read from the log and kind of reread different positions. But you also have the consumer groups feature for certain use cases where you can basically guarantee unique data being read by specific clients. Now let me kind of just demonstrate, without code, what that would look like, although there's a tiny bit of code here. There's some Redis commands here. So you can see the producer, you can see the stream in the middle, and you can see the consumer. And I've got a little command written there called xadd mystream star message hello. That basically sends a record into the stream with a key value pair of message hello. So xadd basically adds a message. The star says, Redis, please generate the unique ID for me. And then, of course, message hello, which is the payload. And then what you could see is the message went into the stream. And what I got back from Redis was basically my unique ID, which is the timestamp and the sequence number that was auto-assigned for me. And then I can save that for future reference. So if I'm the guy who wrote this log entry, I know what it is, and I can go and read from any position after that, for example, if I want to. And then there's a bunch of commands that actually help you read logs. So consumers come in, they can use something called, they can do a range query like xrange, they can do a reverse range query like xrevrange, or they can just use a single data point xread. And what you can see in the return, what got returned was basically the timestamp and then the bag of the key values, which in this case we only had one, and we showed message hello. So that's kind of the very simplistic way on how it works. Obviously, the number of use cases and applications you can build with this are pretty extensive. I also just want to remind, I mentioned consumer groups before. In this example, basically the consumer could read, with these commands that I mentioned, the consumer could read any part of the log. But if you use commands like xgroup, xread group, then you're actually using the consumer group feature. That, as I said before, you could leverage in something like a job queue use case, when you want to guarantee that a message is only processed by a single consumer. So let's see how you would potentially implement a very simplistic chat application. This is kind of an IRC application. You have a channel. You could join a channel. And I've got 3 consumers here. I'm going to refer to the consumers just as their last digit. So I have consumer 3, consumer 2, consumer 9. I don't know if the text is very clear here, but I'll just kind of read it out loud. So consumer 2 put in the first message, and that message basically just says hi. And then consumer 3 basically responded and said, hi, how are you? And that went into the log. But at the same time, consumer 2 was actually not done, and he sent another message saying, how are you? Both of those messages reached the server at exactly the same time. And so what you can see is the assigned unique ID that both of these messages got is almost identical, except for the last sequence number that is different. So that kind of shows you some of that ease of use and power of Redis streams where you don't really have to think about this too much. Redis will kind of do all the heavy lifting for you and basically starts assembling this as a queue. And then we have a third consumer that joins consumer 9 that basically sends a message, hey, can I join you guys? So by now we have kind of 4 messages in the queue. And because we're not using consumer groups, all these consumers can basically see all the messages. So very easy, not only for all of these, for the first 2 to basically see the chat between each other, when consumer 9 joins the chat, he could actually see the history of the chat. And so there are a lot of applications where you actually would want a client that connects, that kind of late binds into a log. You would want that client to actually be able to not just read the log going forward, but also kind of go back in time and read the rest of the log. And so the chat application is obviously a very simplistic example of how to use this, but there are lots of different ways you could use this, whether it's in message brokers, job queues, PubSub, any kind of streaming analytics, lots of opportunities to use Redis streams. We've published a couple of blogs on our website on aws.amazon.com/Redis. And those blog posts go into a bit more detail on Redis streams. The first one is a bit more of a general Redis streams article. And the second one talks more specifically about message queues and how you could think about implementing message queues in Redis. So that's Redis. Now, let's talk a bit about Amazon Elasticache for Redis, which is our fully managed service for Redis. Basically, we launched Amazon Elasticache for Redis in 2013. And we basically launched it because we're doing what we're usually doing, which was listening to our customers. And many of you were telling us that you really like this thing called Redis, but Redis was really hard to manage. Like you didn't want to have to provision this all on your own. You didn't want to have to patch the full stack all the time on your own. Starting to provision it in a highly available way across AZs is a non-trivial effort. Scaling Redis over time is also a non-trivial effort, not just because you need to set up the topology. There's lots of little nuances where replication can back up and all sorts of operational issues. And so you basically came to us and said, hey, can you do the same for Redis as you did for MySQL on RDS? And that's pretty much what we did with Elasticache for Redis. And last thing I also wanted to note is the other feedback we get consistently on these services is, if I have to go and hire all these developers that are going to build these services and keep them up 24/7, right? It ends up also being pretty expensive for us. And so that's why we launched Elasticache for Redis. So that service has been up for over 5 years. It's a very important service for us. It's been very successful. We see a large amount of customers taking advantage of it from caching use cases beyond. And just in a nutshell, there's a few things I think you should keep in mind as far as this service is concerned. First of all, we don't like talking about high performance. We like talking about extreme performance. We see ourselves as the most performant database at AWS. Obviously, there's always a trade-off, right? We're not ASIC compliant and we don't do other things. But what we do well is we can deliver microsecond latencies. We're fully managed. So we manage the whole stack for you. We update the operating system. We keep the stack healthy and keep the service healthy. And if hardware goes bad or anything, we replace it for you and we make sure that the environment is up. We've made it increasingly easy to scale Redis for you. And not only being able to add read replicas, we also enable sharded Redis now. With sharded Redis, you can actually not just scale on reads, you can also scale on writes. And I'll talk a bit later about a recent announcement we made in the past couple of weeks of another significant milestone and getting to a new level of scale. But that has been a huge, huge focus for us. And then from an availability perspective, we give you a multi-AZ environment. We do multi-AZ failover. And probably most important, and this is part of where our secret sauce is, we have very, very deep monitoring. So we're consistently monitoring the systems at a very deep level. And if a fan goes out on a piece of hardware and there's an instance issue, or there's some other issues, we remediate, we do automatic failover, or we take some other action, or we let you take action, depending on what you've configured. Like with most of our services, security and compliance is super important. And so we support Elasticache within VPC environments. We've put a huge focus on going through compliance in the past year. And so we're now HIPAA eligible. We got PCI compliance. We just got FedRAMP compliance. And we're going to continue to expand the amount of compliance programs we're going to go through. We encrypt everything. So we do encryption at rest, encryption in transit, and we also support authentication. And then last but not least, we always try and make sure we have the latest and greatest Redis available for you. I would say to be self-critical in the past year, we really didn't do a great job. Like with Redis 4, it took us too much time to get the latest version onto the service. With Redis 5, we did it under 4 weeks. And really going forward, we're going to have a huge focus on making sure that this service continues to be updated. We don't want to be too fast because we have to test it and we got to make sure it's secure. But I would say within weeks, we want to make sure we have major versions on the service and you can really enjoy the latest, greatest features like Redis streams on this service. So talk about some of the customers we have. We have some really exciting use cases. Expedia, they built a real-time analytics application. Initially, it was not using Redis, and they're getting really bad performance. And they were using good databases, but the problem was they had such scale. They had 200 million messages a day that they had to process that just those repeated database calls were just adding up. And so that's a prime example where even tens of milliseconds or single-digit millisecond was not fast enough in this specific use case. So they took Redis, they used it to cache data as part of this analytics process, and they significantly increased throughput. They reduced latencies by a significant factor. And probably most important, they saved 6 times the cost on their data stores. And that's just because Redis was able to give such fast performance and so much throughput at a very reasonable cost that caching basically allowed them to provision less of the other database that they had. And so that cost saving was very, very significant. Grab uses Redis for many use cases, but I'd say one of the use cases is also for real-time analytics of over 4 million rides they do a day. And kind of similar example, but they've estimated that they save up to 30 to 40% of manpower by basically using managed services and really letting us do all the undifferentiated heavy lifting to make sure that the environments are consistently up and supported. One of my favorites is Peloton. For those who don't know Peloton, it's basically kind of an in-home stationary bike, but it's cloud connected and it's got a video stream and you can take classes similar to going into a spinning class. But it's also got a social component to it. So actually, as you're joining classes, you're actually doing the classes with other people in real time. And so they're using sorted sets, for leaderboards as part of that. So while you're actually, biking at home, exercising and sweating, you can actually see where you rank. I haven't tried Peloton quite yet, but I know that I'm never in the top spot, so I probably wouldn't show up anywhere there. And then last but not least, GE, which is doing session management for a containerless platform that they offer to their developers in-house. And they've been using hash maps to basically deliver session state. If you remember, I mentioned earlier, session state tends to have a bundle of key value pairs. And so hash maps are, really, really nice way to deliver that. What's important about sessions is if you think about your website and the customer logs in and maybe it's an e-commerce site or something else and you need to retain state, making a database call to like a SQL database or some other database every time the customer moves from page to page is just far too expensive and slow. And so that's like a really good example that just by using Redis hash maps, you can both deliver a better customer experience, but you can do like 200,000 of those per second, on a single, relatively small instance. So it's also not going to cost you as much if you actually have to drive a pretty high workload. And then, we have a lot of customers in different verticals. McDonald's uses Redis, Thermo Fisher in the industrials, a lot of media and entertainment. I already mentioned gaming. Pretty much every game has a leaderboard, which means most of these games have Redis. Telcos, ride-hailing, financial services. And now, especially now as we've added encryption and we've added compliance capabilities to the service, we're definitely seeing an increasing amount of traditional enterprises picking up Redis and using it for their mission-critical applications. So let's talk a bit about the service and what's been going on in the past 18 months. So just going back to last year's reInvent, and I'm not going to spend a lot of time on this. Last year's reInvent, we talked a lot about Redis Cluster, which is the sharded version of Redis. And we had just announced online Redis Cluster resharding, which means you can basically change the amount of shards online while you're still serving requests. And so if you need higher write throughput or more capacity, you can basically do that online. That's also when we announced encryption everywhere, encryption at rest, encryption in transit. And we also announced HIPAA eligibility. 2008, I think, became even more exciting just with the recent announcement of support for Redis 5. We just announced support for M5 and R5 instances, but this announcement is more special than some of the past instance announcements we've made. So I'm going to talk in a bit more detail on, what that announcement was about and why you should care about it. We've seen customers use a lot more Redis, but also use a lot more Redis at scale. And so the previous limitations of 19 nodes in a cluster, or 15 shards, just weren't working for some of our customers. So we've just announced support for much bigger scale. We can do 250 nodes, in a single Redis cluster today. We've also increased the amount of shards we support from 15 shards to 250 shards. And if you think about it, every shard, basically the master node defines how much memory you use from a write, you can use from a write and data perspective, right? The read replicas don't count. And so going from 15 shards to 250 actually means that the amount of unique data you can save in our environment now is over 16-fold than you could do before. So it's a very, very significant change for our customers, especially those who've been pushing us, right, to go to a higher and higher scale. We also, in the last year, open sourced our encryption in transit support. So last year we announced encryption in transit. We built that encryption in transit is a very hard feature to build. It's got to be operationally sound. It's got to be really secure. We also used a library that we open sourced as Amazon called S2N, which is basically an OpenSSL replacement, which we believe performs better and has a lot of benefits. Especially, it's a much more lighter weight, simple library, so it's easier to kind of also make sure that it's kind of remains secure and so on. Until we leveraged that Apache 2 licensed S2N library that we had open sourced a couple of years ago, and basically built encryption in transit. And then we open sourced the encryption in transit capability. We still haven't gotten that all the way upstream into Redis, but we're definitely, talking to the Redis creator to see if we can kind of, continue to work on that patch and make sure that it fits kind of the coding standards of Redis, so we can hopefully get into upstream Redis. With that, we were able to get through PCI compliance, FedRAMP compliance, and we continue to go through the rest of the compliance certifications. A lot of your feedback to us has been, I don't really understand what's happening. If something goes slow, the CPU metrics aren't really clear to me. Redis is single-threaded, so how can I really kind of, draw a parallel between CPU metrics and how busy Redis is? The simple answer is it's actually really hard. So I don't have the perfect answer for you, but we did give an additional metric that gives you a specific metric on the Redis process itself. So not just the machine CPU metric, but also the Redis CPU metric. I'll talk about some of the futures in a couple of minutes, and you'll see that even this metric we'll have to think about how that fits into the future, but it is another way for us to kind of give you some more transparency about what's happening. The other thing you asked us for is, until today we didn't support snapshots or auto failover with T2s. The primary reason was that T2s are just very small instances, and we were concerned that they weren't operationally sound enough for production environments. And we still don't recommend them today because you could run out of CPU credits and then bad things could happen. But we did want to make sure that you could use T2s in dev and test to build environments that were very comparable, at least in configuration, to the production environments you had. So for that, we basically launched support just a few weeks ago for snapshotting on T2s. We also support auto failover for T2s right now. And we'd love to continue to hear your feedback on what you want to see us do around the kind of lower end of the instances. And especially as our hardware keeps on getting better at AWS, I think there's going to be a lot of interesting opportunities in the future with actually some of the lower end instances to deliver some nice production capabilities. And then last but not least, one of the things that we were missing is we weren't supporting in-place version upgrades for Redis cluster, which is the sharded Redis. And that's also something we announced. So if you look at Jeff Barr's blog where he describes the Redis 5 launch, you'll see that he actually kind of shows 2 screenshots. And he shows how he migrated his Redis 4 cluster to Redis 5 in one click of a button. So our big goal here is really to make management as easy as possible, give you as much flexibility as you can. We still have a lot of work ahead of us to continue to push the envelope on how easy and scalable the environment is. But there's a lot of investment we're making in making sure that the service continues to meet the needs of your applications and the increasing amount of variance in use case that we're seeing around Redis. So let's talk a bit about these new M5 R5 instances. So first of all, M5 and R5 instances are actually quite special. Our hardware teams are really innovating on the hardware, and they built a system called the Nitro system. Nitro system is a way for us to offload some of the hypervisor work, security, networking, and so on, off instance, and basically freeing up a lot of the CPU to actually do what it's supposed to do, which is actually run your applications. And our goal, and pretty much what our hardware team has achieved, is by using this AWS Nitro system on the M5 and R5 instances, and many of our future instances are going to use it too, we're basically delivering virtualized instances with the performance that is pretty much indistinguishable from bare metal performance. And so that hypervisor overhead is going away. And that is especially important in something like Redis and in-memory, because when you're in memory and you're running that fast and you're doing system calls and you're doing memory management, that's where you're really going to feel it. You're not going to feel it quite as much on like a Java-based application because there's so much overhead from just the Java runtime, the memory manager. You'll feel it, but not quite as extreme as you'll feel it on Redis. And so what we did here is we ran some benchmarks. And these are pretty simple benchmarks. They're key value benchmarks where the values are 200 bytes. It's an 80% read, 20% write workload. So it's not the most scientifically perfect benchmarks, but it's pretty good to kind of show you, kind of what step function and performance you could assume. And if we just take, vanilla R4s and vanilla R5s as is with Amazon Linux, you can see that there was a dramatic jump between the pink and the purple there in performance. In fact, the jump is somewhere between, depending on the instance type, between 59 and 144% throughput improvement. We also saw latencies go down 23%. So not only are you able to use a lot more of it, which I think is probably the primary benefit because that really helps you manage your cost, but you're also getting much better latencies. But that was not all. In addition to that, we were like, hey, we just got to try and get the performance up as much as we can. And we worked with our hardware team, and we put a lot of effort into really optimizing the kernel configuration, the hypervisor, and so on. And that's that red bar. So kind of when you get Elasticache for Redis, you're getting Redis on Amazon Linux, on the Nitro system, but also we've really spent a lot of time just to configure the networking queues, the interrupts, the timers, lots of things on the system just to make sure you really are maximizing what you get. And in some cases, just those configurations actually added another 30% in throughput. So these are not negligible numbers, especially if you start running Redis at scale. This really adds up. And with the introduction of this, and then the 250 node clusters, you can actually run an environment like this now on up to 170 terabytes. So you can run some really big R5 instance-based Redis clusters. And probably last thing I should say is, these are built on custom Intel Xeon designed for AWS. And just this system as a whole is a really, really awesome system. So if you're running on R4s today, I definitely would recommend that you try the R5s. And in fact, the R5s are also cheaper than the R4s on a per hour basis. So there's really almost no reason not to use the R5s, but give it a try. It could be application specific, but these are very, very reproducible benchmarks just with a very simple kind of key value request paradigm. To give you a short case study for the R5, so R5s just came out on Elasticache came out a few weeks ago. And then after they came out, Epic Games got in touch with us. They're using Elasticache for Redis for Fortnite. They're telling us, we have a huge surge event coming up. We want to dramatically increase the cluster size. And because we have online, scale out, scale down support with Redis cluster, that's definitely an option. But they were already running at such a large scale that not only would it have been operationally complex to continue to push that scale for them, but also would have gotten very, very expensive. And so, we kind of, when we heard that, we're like, maybe we can do something good here and actually make sure that they're not spending any more money, but are meeting their surge event requirements. And so we suggested, why don't you go and try the R5s? We just got them out now. They're super optimized. They seem to fit your use case. And they basically migrated that environment to R5s. They didn't have to scale up whatsoever. And that surge event went through without a breeze. And in fact, they told us afterwards that they saw the CPU time go down by about 2/3 while that event was actually going on. So they saw a super big impact, not just from a performance perspective, but ultimately also operational risk and cost went significantly down. Now, we have a very rich roadmap over the next year. I'm not going to talk through our roadmap. You'll see that roadmap evolve as we make announcements. But I did want to highlight a few things that were kind of very short term. They're kind of almost out, but we didn't quite get them out in time for reInvent. So a few kind of cool, interesting things. The first one is this performance journey with the M5 and R5 instances really gave us the appetite to try and do better. And so we've actually done even more work since then and have looked at how can we actually leverage, as you go and provision like R5 extra larges and up and multi-core environments, how we can really make sure we take more advantage of the cores. So quite shortly, we're going to see another step function in throughput coming out by us having done more work on really optimizing the network processing. And that's going to just kind of come out as part of Redis 5 on the R5 and M5 instances, and actually probably also support some of the older instances. And you are going to get those dramatic throughput benefits as part of just using our instances. The second thing, which may seem like a really small feature, but we've been consistently asked to do this, is supporting the rename support command. Lots of our customers, as you put Redis into production, the nice thing about Redis is it's really easy for developers to connect to it and kind of look around and, while it's in production, kind of see what's going on. However, there's also a few commands that if you run them on a production environment by mistake, just with good intentions of trying to figure out, what's going on in an environment, you could have a significant negative impact on your Redis environment. One of the favorite commands that people like running is keys, which basically returns all your keys in Redis. And don't try this at home. If you have a really heavy-duty Redis environment and you go in and you run keys, your boss isn't going to be very happy. And so those are the kind of, those are the kind of commands that we've been asked, to rename so that, people accessing the environment don't just by mistake forget, or maybe they have a development environment in one window on their console, the production on the right, and never happened to anyone. You wrote the wrong command in the wrong window or the right command in the wrong window, and things went bad. Trying to make sure we eliminate those kind of issues. And then last but not least, we've also been asked to make service patching easier. Today we have a service window which you can select, and then we'll make sure that security updates and other updates are basically patched within that service window. But we've gotten a lot of feedback from you that it's great that we give you the opportunity to configure that service window, but your business is changing all the time. What was a good service window 2 months ago is not a good service window this month, and you want to have a bit more control over when these things run. So we're going to be introducing something called self-service patching, which means that we will actually let you know when you have to patch. You'll be able to patch through an API call or through the console just by hitting a button, and then the patching process will start, and we're going to go node by node and upgrade your environment. Now, if you don't take action, at some point we're going to do it within your service window for you. But at least this way, we're going to give you the choice to take ownership of the patching ahead of time and doing it at some time which is convenient for your business. There's lots more sessions about Redis at this conference. Today at 3:15, we have one of our lead specialist SAs that's worked with most of our large customers do a deeper dive into Redis and design patterns around in-memory data stores. Tomorrow we're going to have a chalk talk. If I got your attention with Redis streams and you have appetite to learn more, there's going to be a really nice chalk talk tomorrow where some of the folks on my team are going to take you through Redis streams and show you how you can build an application with it. And then on Friday we have another hands-on tutorial or workshop on Elasticache for Redis. So I hope within this session I was able to meet both objectives. Those who are not using Redis, I hope I built enough appetite for you to go and try Redis right now. And for those who are not using Elasticache, I hope you'll give us an opportunity to show you what we can do. We have time for questions. First of all, I can take questions right now. There's also my email address up on the screen. And you should feel free to email me any questions or also feedback. If there are things you would like us to do better on the service, things you would like to see, shoot me an email. And we would love to get that feedback. And frankly, our roadmap is really defined by the feedback you're giving us. So do we have any questions here? Yeah, go ahead. Do we have support to support what? Okay. You mean like cross-region replication? Okay. The question was, will we ever support cross-region replication? I'd say cross-region replication is an ask that comes up, on multiple database services, right? We just support it on Dynamo. We've had some other services where, we've talked about it. So it's definitely something we're kind of thinking about as part of feedback we're getting. I can't tell you any timelines or any specific roadmap, but it's good feedback, and it's feedback that we've heard. Anyone else have any questions? Can't see. Yeah, go ahead. Oh, the question is what is the maximum size for the value of Redis streams? When you say value, you mean the overall stream or the record? That's a great question. I don't know. I know a string in Redis, I think the maximum is 512 megabytes. I don't know if that equates to Redis streams. That's a great question. It's something I got to check out. Excuse me? Okay, yeah, send me an email and I'll check it out. Yeah, go ahead. Oh. Yeah, so the question is accessing ElastiCache the same as accessing Redis Anywhere with, for example, PyRedis? The answer is yes. We're compatible with all the drivers. Some drivers are better than others, but they do work with us. We do typically recommend for production environment to use what's called Redis cluster, which is not the best name, but Redis cluster is the sharded Redis, which has smart clients that actually figure out what the topology is, and then failover is much faster, and a bunch of other benefits. So for Redis cluster, not all clients are equal. Some are better than others. You can also send me an email, and I can make a recommendation in your preferred programming language, which client you should be using. Yeah, go ahead. How would I compare the new Redis streams with Kafka? I have no idea, to be honest. I mean, I would say that at a very high level, I'm not a Kafka expert. I mean, I know Kafka okay, but not great. I would say, Kafka is, Kafka writes to disk, right? It will support a lot more than what you can support in DRAM with Redis streams. It's probably, as a result, also going to be a bit slower. Kafka has a very broad ecosystem, right, of adapters and so on. So I would say that, my guesstimate is we're going to see a lot of customers who use both, right? So for log analytics streaming, like operational logs, you'll probably use Kafka because you can basically retain those logs for like 24 hours, and make sure you can kind of, not pay for in-memory, right, for all of that. But then I think for a lot of these kind of interactive, real-time applications, Redis Stream is going to be awesome. And I think it's at the real-time level where I think we're going to see quite a lot of adoption of Redis streams, including replacing some of the things you could do in Redis before without streams, like pub sub and other patterns, which may actually be more effective to do with Redis streams. Yeah, question in the back? Yep. Yeah. Okay. Yeah. So the question here was, we have a DNS entry for master, of course, but we don't, like Aurora MySQL, for example, has a single reader endpoint, right, that gives you basically all the read replicas. That is something that's on our roadmap. So it's something that it's not the first time we've gotten that feedback. It's something we want to make sure that happens. So it is. There is a blog post actually on how you can work around that and build it on your own. But our goal ultimately is to make sure that our service delivers single reader endpoints. Yeah, in the back, and then we'll get to you. Yeah. So the question was, are we going to have support for Redis modules on the roadmap? I think we really are looking for feedback on that. Like, send me an email, what your use case is, and so on and so forth. We have seen that from some customers who've had some interest in things like Graph. Generally, Neptune is a better fit. Neptune is one of my other services, which is a Graph database service. And so, we are thinking about, hey, could we use a Kinesis stream or something and then write into Neptune and write into Redis at the same time? I do think like purpose-built Graph databases, especially as Graph database is very difficult to build and you need to scale to billions of edges in many cases, are probably going to be more cost-effective than doing it in Redis. But we are definitely listening to kind of general feedback on Redis modules. And if we get enough feedback that certain modules are needed, we'll build those modules. Yeah, JSON is also a nice module. Yeah, go ahead. Yeah. Yeah, so the question was, do we have any plans on improving automatic failover? We're constantly trying to improve it, both the monitoring and the auto detection, and then also the failover time. So Redis cluster gives you some benefits, but it's still not sufficient, right? Because one is the monitoring time, and then the second piece is actually to trigger the failover. So that is a big area of focus of ours, and I think you're going to see us in the next few months get continuously better on really eliminating those gaps. I don't remember the exact window. I think detection can, depending on EC2 and things, can take probably 30 plus seconds, but I'm throwing these numbers out without remembering the exact numbers. Redis cluster itself, once you trigger the failover, I think goes much faster. It's probably about a 20-second failover time, but it really depends on the scenario. And we are working on reducing that failover time significantly. Yeah. I think we have time for one more question. Yeah. Yep. Yeah, so I'm not the Hyperlog expert, to be honest, on the implementation. If you send me an email, I'll send you a link to the paper also. But it's basically, it doesn't change the functionality, but I do believe it makes it both faster and also it is more accurate, especially when you merge Hyperlog logs together. So this is kind of another kind of significant improvement for Hyperlog logs. What use case are you using it for? Okay, using it for counting. Okay.